Alright, the first thing that I'm going to cover here is I'm going to kind of go learning target by learning target, make sure everybody's clear on exactly what my expectations are going for tomorrow. So I'm going to gotta go through every learning target. So first of all, learning target 1. You can look up what that is, but I'll just tell you that it is solving one-step equations. Okay, solving one-step equations. So I'll write a couple of examples. Again, you should have a separate sheet of paper out. You should be writing this because I'm not going to ask you to write a whole bunch, but I'm just going to kind of go through here and write a few. Okay, we'll call that number 1, I guess. We'll call this number 2. Say 12 equals x minus 2. Okay, and then I'll do number 3 down here. Another solving. Let's do 1/5 x. What's that problem? Equals 3. Okay, and then we'll do another one. Number 4, we'll say it is x divided by 3 equals 8. Something like that. Okay, so feel free, if you want to pause right now and practice, just to and then watch it and see if you get it right. That's fine, because I can tell you right now there are 4 questions on the summative and the formative that look like this. There's one that has to do with addition, subtraction, multiplication, and division. So your call on that one. Okay. So first of all, we're going to draw a line because we always start there. We always draw a line first. You got to do it. Okay, and then from here, remember, we always just ask ourselves. Okay, we write. You don't have to write PEMDAS, but I say, if it helps you remember when we're solving for a variable, we use PEMDAS backwards. That's kind of our little checklist that you guys are starting to be able to do kind of in your head, and that's what I'm trying to get you to, because realistically, when you solve equations next year, the year after, and for the rest of your math classes going forward, you're not going to write PEMDAS and go backwards. You're just going to know that's how you solve an equation. Okay? First thing you ask yourself is there any addition or subtraction happening to the variable? That's the first question. Specifically, is there any happening to the variable? So if I am adding 9 to x, I need to undo that with something called inverse operations. Inverse operations. Inverse operations, inverse just means opposite, and plus, the inverses, like plus and minus are inverses, and then multiply and divide are inverses. Okay, multiply and divide, those are inverses. So we need to undo adding 9, so we're going to take away 9. We're going to take away 9 from this. Okay, over here, this is to kind of get rid of that. It's not an x, I'm just trying to get rid of it because it eliminated itself. I'm left with x on the left, and then over here I just do that problem. 13 minus 9 is 4. Now remember, the last and maybe the most important step that you're going to do is you are then going to rewrite the problem, now putting the solution for x in there. So x plus, no, I'm sorry, I didn't want to write x plus 4. I want to write 4 and then plus 9, because that's what that says right there, 4 plus 9. And then do it. You can do it in your calculator or whatever, just to make sure that it is indeed give you 13, and it does. Okay, going over to this one. Draw our line first of all. Now we ask ourselves, same question, is there any addition or subtraction happening to the variable? Yes, there is. 2 is being taken from the x. So we're going to add 2 to both sides. Add 2 to both sides. We're going to draw a line just to kind of separate it. Over here I'm left with x, and then I know that 12 plus 2 is 14. Now I take it and plug it in. So I take my 14, take it around, plug it into there. Is 14 minus 2 12? Yes. So I know that that is absolutely right. I have no questions whether or not that is a right answer or not. Okay. Here we go. Come on, pen. Okay. I have 1/5 x. Okay. Now I'll write PEMDAS again just so that you guys can get a visual. Okay. Do it backwards. We ask that first question, is there any addition or subtraction happening to the variable? No, there is not. Okay, so there is no addition or subtraction. So we go to the next step. Now, is there any multiplication or division happening to the variable? Now, this is where I see the biggest confusion. And the reason there's confusion, I think, is because I've told you all year that all fractions are division problems, which is true. 1/5, the fraction 1/5 is 1 divided by 5. It is. But again, listen how I'm asking the question. Is there any multiplication or division happening to the variable? We want to know specifically, what is the fraction 1/5 doing to the x? And hopefully all of you are saying, well, it is being multiplied, because anytime a number is touching the variable, we know that that's multiplication. The 1/5 is just the coefficient here. So we're going to undo multiplying by a fifth by dividing by 1/5, dividing by 1/5. Okay? And then we know that we're left with 1x because 1/5 divided by 1/5 is 1. So that's what we are getting there. X equals, and then 3 divided by a fifth. You could do it in your calculator, but just for good memory, remember, dividend stays the same, divide becomes multiply, and then we use the reciprocal of 1/5, which is 5 over 1. We learned that the answer is 15. Okay? And then get in your calculator, you do 1/5, you're going to multiply that by 15, and see what it gives you. It will give you 3. Okay? Next one, okay, for solving, draw your line. Is there any addition or subtraction happening to the variable? No. Then I ask myself, is there any multiplication or division? Yes, there is. X is being divided by 3. So we need to undo that by multiplying by 3. Now, I don't like to use an X here. I should use a dot. Okay, multiply by 3. Over here, I'm left with X. 8 times 3 is 24. Okay, and then I plug it in just to check into right there. 24 divided by 3 is definitely 8. Okay? All right, let's go on to learning target number 2. Okay, again, make sure you're writing these on paper. I'm going to do learning target number 2 and number 3. Okay, so I have these 3, and again, feel free to write these if you want. That's fine. Again, it's just good practice. You could pause and try them real quick if you want. Again, good practice. The first thing we're going to do is we're going to write an inequality describing this. Now, I always told you, always start with a variable. Now, it doesn't matter what that variable is. It can be x, it can be y, p, r, doesn't matter. You always start with a variable and then whatever the number is that's given. Okay? For this one, we are doing something with the number 3. Okay? Now, we know that my 4 inequality signs are less than. Looks like an L for less than. There is greater than. Remember, the big side comes first. And then there is less than or equal to. And then there is greater than or equal to. So, if I can have at most 3 dogs, does that mean I could have exactly 3 dogs? Yes, it does. I know I can have exactly 3 dogs. So right away, I know this is an or equal to, because if I have at most 3 dogs, I can have 3. So that eliminates these two inequalities, because I know it's an or equal to. Now it's all about just putting in the right inequality symbol. Okay? At most 3 dogs. Does that mean I could have 4 dogs? No. If this were 4 right here, this would be a greater than, right? But that's wrong, because at most 3 dogs would imply that I have 3 or less. So therefore, I know that this is, the number of dogs I have has to be less than or equal to 3. Okay? Now let's practice graphing real quick, just to be a little reminder to you. Okay? We know we put 3 right in the middle, and then we just go one number below it, one number above it. Okay? Got to remember this little thing. Remember, open dot we use for less than or greater than. We used a filled in dot for when we're including the or equal to, when we're including 3 as a solution. Since we are including 3 as a solution, this is going to be a closed dot. Now, we're going to shade where my solutions for x would be. Where are my solutions less than or equal to 3? Well, they're this way. So there's your shading. And that means I could have 3 dogs, I could have 2 dogs, I could have 1 dog, I could have 0 dogs. Okay? Let's go to the next one. Again, pause these if you need help. If you want to try them and then check. Okay, I'm going to start with a variable. I'm going to start here. Okay? Now, if I have more than 24 pens, again, these are my 4, so I'll rewrite these. These are these. And those are my 4 inequality symbols. Okay? And I know x is representing the actual number of pens that I have. We don't know how many pens I have. Okay? But if I have more than 24 pens, can I have exactly 24 pens? No, I can't. So now I'm going to eliminate those two. Because if I have more than 24, that means I have more than 24. So I have at least 25, essentially, is what it means. Okay? So how would I show my pens, the number of pens that I could have, being greater than 24? Again, my thing, my little monster here, whatever you want to call him, he's trying to eat the larger one. And since I have, this is what I have, more than 24, it's going to try to eat the more than 24. Up here, I have at most 3 dogs, so that means I have 3 or less, therefore it's trying to eat the larger one. So there's my inequality. So now I'm going to draw my number line. Okay, I'm going to put 24 there, 25 there, 23 there. I got to determine if it's going to be an open or a closed dot. I go up there and remember, oh yeah, it's not including 24 because there's no or equal to, so that's going to be an open dot. Where are the solutions for how many pens I could have? This way? No, I can't have 23 pens. I can have 25 or more. Okay? Okay, here we go. Start with your variable. Start with the number that's given. Now, I have at least $150. First of all, I always ask myself, can I have exactly $150? Yes, I can. If I have at least $150, that means $150 or more. So I know I've already, draw my symbols over here again. I've already eliminated these two, right? Because I know it's an or equal to, because I know that I can have exactly 150 bucks in the bank. Okay? So if I have at least 150, that means that I could have more than 150. Therefore, I know that my monster here is going to want to eat the X because I know that I have at least 150, which means I could have 160, I could have 200, I could have 400, right? All those would be solutions, and it's trying to eat that one. Okay? Graphing this on a number line. Okay? We put 150 in there. We put 149 in there. And we put 151 in there. I know it's going to be a closed dot. Where are my solutions? To the right. Okay? So that's that. All right, so that's learning target number 2 and 3. Also, be prepared to be able to actually find the inequality from this. For instance, if I drew a number line here and I said this, put 2 and then 3 and then 1, and I say, okay, like that, you'll have to write an inequality based on that. Okay, well, you start with wherever, you start with a variable, you start wherever the dot is, it's over the 2, and then first thing I recognize is an open dot, so that would eliminate these two. So it's either this one or this one. And what is it showing? It's showing X solutions greater than 2. Okay? Okay, so now we're going to kind of combine learning target number 4 and 5. Okay? Learning target number 4 and number 5. Okay? Area of a triangle, area of a parallelogram. Okay? The first thing you got to know here is you got to know your formulas. Okay? You got to know the formulas, because if you don't know the formulas, you're not going to have success. Okay, it's just that simple. Area of a triangle is 1/2 base times height. You got to know those. If you don't, you better, again, I don't like using the word memorize, but this is a memorized activity. Know the formulas. You got to know those too. Okay, got to know them. Okay, so let's look at these. Okay, we got to remember that the base and the height always forms at a right angle. And again, if you want to pause this and try these, more power to you. That'd be a great practice, great study session, okay? So when I look at this first one here, I see that this slant is 8 meters, this is 6 meters, and this is 10 meters. If I asked you to find the area of this, could you do it? Absolutely not. You do not know a height. The reason I know that that neither 6 or this and this, I know those are not the height because they neither of them meet this base at a right angle. That's not a right angle right there. That's certainly not a right angle. So I don't know it. So if I were to give you that on the test, you better write cannot do, don't know the height. Okay? So I'll go ahead and put it on there now. You can add it too. Now I see it coming straight down from the very tippy top, straight down at a right angle, and let's just say that that is 5. Okay? Now I'm ready to do this. So let's do our area formula. I know it's a triangle, so it's going to be 1/2 base times height. Okay? You don't really need to draw the line there. You can if you want, but 1/2, I know the base is 10. I know that the height is 5. So I do that problem. 1/2 times 10 is 5. Times 5 would give me 25. Okay. And then obviously we know we need meters squared. So real quick, let's count the points. You're going to get 1 point for that right there, that formula. Your second point is going to come in the form of the answer. Your third point will come in the form of the units. So that would be 3 points on that problem right there. This one here, same deal. You know this is the base and this is the height. The reason you know that is because that's a right angle. This is a distractor, just like these two were distractors for area on that one. Okay, the base and the height always has to form at a right angle. So again, here we go. We do 1/2 base times height, which equals 1/2 times 12 times 16, which is going to give me 96 meters squared. Okay? 96 meters squared. Again, to count the points, there's my formula, there's my answer, and there's my units. Now, on the test, you may be asked, whoops, I don't want to erase. It doesn't matter, I can erase it. You may be asked where the triangle formula comes from. Where does that formula come from that allows, why do I take 1/2? Why is the formula this? Where does it come from? Well, it comes from this right here. Okay? Remember, every triangle can be put back together and form a parallelogram, right? So you can see I'm going to come straight up here, and I'm going to come straight across. And now I've created the rectangle. Okay? I've created it. Okay? It has the same base and the height. Okay? The base is this. You guys all called this the base. Okay? The base, I don't remember what it was now. I think 18 or 16. I can't. Hold up. The base was 12 and the height was 16. Okay? So we know the base was 12 and the height was 16. It's still there? Meters? Okay? If you look at the rectangle that I have drawn there, wouldn't the height still be 12 times 16? That's how I'd find the area of the whole rectangle. You guys see what I'm saying? So why do we take half? Because that's exactly where it comes from. We're splitting that parallelogram in half. Okay? Down here, I know this is a rectangle because it has all 90s. Opposite sides are the same, so I know that this is 9 meters. I know that this is 6 meters. Okay? I know that's 9. I know that's 6. Okay? Now I know the formula, which I'm going to write every time we have a problem like this, is that. Then I'm going to do base times height, 9 times 6. It's going to give me 54 meters squared. Again, the 3 points are formula, answer, units. This one here, if I were to give you this problem right here and say find the area of it, you had better say you cannot do it. And if you already attempted it, and if you got 60, you did it wrong. This right here is not the height of the figure. It's not. That's just a slant height. Those are distractors. Remember, the base and the height always have to form at a right angle. I have to know this. Now, if I know this is 4, now I can figure out the area by doing area equals base times height, which is 20 times 4, which is going to give me 80 meters squared. 3 points, 1, 2, and 3. Okay? So remember, base and height always have to form at a right angle. All right, a little more practice with learning target number. This will also be learning target number 4 and 5. This is actually learning target number 6 over here, so we'll practice that in a minute. But this one here, this is one where you're going to have to do a little bit of different work. Now, you're given the area, and you're being asked to find the h, the height. Okay, so how do we do this? Well, the first step always remains the same. 1/2 times base times height. Now, you plug in what you know, just like we did on the previous one, right? You knew the base, you plugged it in. You knew the height, you plugged it in. Up here, you knew the base, you knew the height. You plugged it in and found the A. Now we're doing the opposite. We are given that the area is 24, okay? And we know that this is 1/2 times h times 8. Now, I wrote it like this for a reason, okay? I know that technically the base is technically this and the height's technically here. I'm trying to show you that it does not matter which order you write it in. Remember, 3 times 8 is the exact same thing as 8 times 3. Same thing. So it doesn't matter. So I wrote it like this just so you guys know that if you're ever given the height and then asked for the base, it doesn't matter. Okay? You can rearrange this however you'd like and make it be 1/2 times 8 times h. Okay? Now, this is where I saw a lot of confusion. I saw a lot of people trying to divide by half and then divide by 8. Don't do that. We always do what we can do on one side of the equal sign first. And you do 1/2 of 8, which is 4, times h. So we're going to bring down h and 24. Okay? Now we're just looking to solve. We're going to ask ourselves, just like we did on learning target 1, is there any addition or subtraction? No. Is there any multiplication? Yes. We divide by 4 to both sides to undo multiplying by 4. And we get that h equals 6. So you go up here and you say, okay, I know that my height is 6 inches. You shouldn't stop there. Okay, well, first of all, I just want to make this note. This is not 6 inches squared. Area is the only thing that's squared. This is just a distance, just the height. Okay? So, now, what I would do if I were you is now I would just check it. I would write my formula again, and I would just check and make sure that I did this right. 1/2 times 8 times 6. Make sure that this gives me 24, so let's check. Half of 8 is 4. 4 times 6 is 24 inches, inches squared. Isn't that what we said it had to be? Absolutely. Okay, so that's just a good way to check. Again, I'm trying to get you guys to hopefully test out of this thing. Okay, trapezoid. Okay, I'm going to do the area equals 1/2 the height. Actually, yeah, 1/2 the height times the sum of the bases. Again, a big long formula that unfortunately you do have to memorize. Okay, so I do 1/2 the height. I know the height's the distance between the two bases. So times 6, and then it's 10 plus 24. Those are my two bases. The bases are always the parallel sides. Okay, I do this first. I get 34, and then it's 1/2 times 6 times 34. 3 times 34 is, I think 102, but let's check. 102 inches squared. Again, here's your 3 points. Your formula, right there, your answer, and your units. Okay? All right, so now, you know there's going to be one like this on the test. I told you today. Okay, it's going to ask you to decompose this. Decompose. Decomposing means to break the shape into smaller shapes. Now, I know this trapezoid is not drawn very well, but that's supposed to be a right angle. So just if it says it's a right angle, it's a right angle. So you should know right away that you're gonna decompose this thing into a, redo that. You're gonna decompose this thing into a rectangle, and then you're going to also decompose it into a right triangle. And I'll show you how here in a minute. I know those, I drew them real big, and I'm just doing that for a reason, so that I'm trying to get you guys to see something. Okay? But I'm just showing you that this right here, in red right there, that's going to be that. So, where I got that is I know that I'm going to draw a dotted line going straight down from where that vertex ends, because I know that'd be the only right angle I could get right there, and that would be a right angle, and obviously that would be a right angle. This is my rectangle. So this is this. So we can call this letter A. We can call this letter A. Then I got this triangle. We'll go ahead and call that B. And we'll call that B. Okay? So you're going to find the areas of each one of these. Okay? So I look here and I say, okay, I need to know that by that distance. That's what I need to know in order to be able to find the area of this. Okay? So I look over here and I say, okay. As I look at this right here, I'm saying, let me do this in a different color so we can all see, so I can color code it a little bit. I'm trying to find that green and that green side. Now, it's not listed here. Remember, 10 is the whole distance from the one end of the trapezoid to the other end. Okay? So, you got to remember the definition. Okay. Anyway, what I was saying is this 10, it's actually showing the distance of the whole base. So this is where you got to use your definition of what a parallelogram is. And a rectangle is a type of parallelogram. Okay? We know that if this right here is 4, and if this is a rectangle, then I know that this is also 4 meters right here. This is pretty easy because I know that it is here, right there, is 6, and that's obviously going to stay as 6. So I know the area here is going to be 24 meters squared. Okay? And that's 24 meters squared for that rectangle right there. This triangle is where the work comes in a little bit more. Okay? Now you know that it is 10 from there to there. So if you know that this light green part right here, if you know that this is 4 right here, well, you're going to take 10, your whole distance, and then you're going to subtract out the 4. And that's where 6 meters is going to come from. Okay? Now, this height right here, well, think about it. I drew it right next to this for a reason. If this is 6, then this had got to be 6 because it's a rectangle. So this would also be 6. Okay, so I find the area of this. I know that the area formula is area equals 1/2 base times height. Okay, now it's easy. I know the base and the height, so it's going to be 1/2 times 6, which is going to give me 18 meters squared. Okay, well, what do we do now? Well, you're going to take that, and you're going to take that, and then you're going to add them together. 24 plus 18 is going to give you 42 meters squared. Okay, so that is how you do it. And then you could always go back and do your regular formula, 1/2 the height times the sum of the bases, just to, check, just to make sure you get that, because you better get that. Okay, so that is definitely, you can check that to make sure you did that correctly, okay, with the formula. Okay, so here, these are a couple of from like learning target number 7 and 8 that I want to just review real quick. That could definitely be on the formative. Will be on the formative, not could be. Like this one, for instance. This is a one you're definitely going to see. And basically, what it is it's going to say find the area of the shaded region, which, as you can see, is the green region. Okay. So how you do that is you have to figure out the area of this entire thing. What I have outlined kind of in black there. Do you guys see that? That parallelogram. Okay. So when we find the area of the parallelogram, okay, which is going to be, if my pen will let that happen, it's going to be area equals base times height. We write the formula every time. Then we just plug in what we know. I see that this is the base. I know this right here. This side is 15 up here because, remember, opposite sides are congruent and parallel. So that means this does not mean this is 8 right here. That's wrong, right? Because 8 is not this slant. It's this height. Okay, it's meeting at a right angle. Okay, so that's not 8. So I know that my area here is 15 times 8. Okay, 15 times 8 is 15 times 8 is going to give me 120. And then, of course, you got to know we got to have units on there, 120 centimeters squared. Now, that's the area of the whole thing. That's if I gave you this thing and it looked like this, if it was all covered. Okay, it's all covered. All of it is shaded. That whole thing has an area of 150 or 120 centimeters squared. Okay, we don't want to know what the area of the whole thing is. We want to take out that unshaded part. Okay, sorry about that. Had somebody at the door. I think what I was saying is I just found the area of the whole thing, the entire thing. We want to subtract out this area right here because we're saying we don't care about that area. We want it to be out. So imagine taking scissors and then cutting out that little square in there, okay? And that would give me the area of the whole thing. So what we're going to do now is this area is the entire thing, okay? The inside square then, the area of that, again, we always write the formula, base times height, and then it's going to be 6 times 6. We know is going to be 36 centimeters squared. Okay, so that's the area of just that square. The 120 down here, that's the area of the whole thing, the entire thing. Okay, so remember, I told you subtraction's used for one thing. It's when you know the whole and you know a part and you want to find the other part. And that's what we're doing here, okay? We're going to take the whole area, which is 120, and we're going to subtract 36, and we are going to get 84 centimeters squared. Okay? And that's where it comes from. All right, let's go over here and look at this next one here. Be prepared to do one like that previous one. We did this one here today in class. I changed the numbers up a bit. Okay? Remember, you want to find, you took this, what is it, a hexagon, I think? Yeah, hexagon, and you split it into 6 triangles. 6 triangles. Okay? Then what we're going to do is we're going to find the area of one triangle. So that's, we got to write the formula, of course. 1/2 base times height. We plug in what we know. So we go, okay, well that's going to be 1/2. I know the base always meets at a right angle, so that's just why it's written out there and not in there, but this is 6. It's the same length. Okay, it's 1/2 times 6 times 12. Okay, and I find that my area is going to be 36 inches squared. Okay, that's the area. But again, that, guys, is just the area of one individual square. I'm begging you guys not to make that mistake tomorrow on the test, because this is just like this. If I said what's the area of the shaded on this one, like if this was shaded, where I'm doing red right here, the area would be just simply 36. Okay, 36 inches squared. So that would be 36. That's only a part of the whole thing. We want to know the area of the whole thing. So what we have to do is we got to take 36 and we got to multiply it by however many triangles there are. And since there are 6 triangles there, we're going to do 36 times 6, and we're going to get 216, and that's going to be inches squared. Okay, so sure, there's probably a formula out there that has us find hexagon area, but we don't care about that formula. We can break it into triangles and find the area that way. Okay, 2 more here. Okay, let me, if I can scroll down. Okay, you can see this is a true composite shape. Okay, this is a true composite shape. Okay, and I want to erase this, but I don't want to erase. All right, it's a composite shape in that it's some things put together. So you can see it kind of looks like an L or maybe something like that. But anyway, you're going to break this thing down. Now, there's a couple different ways you could break this thing. I mean, you could break it just like this, right, and make a rectangle and a rectangle that way. Or you could break it going across. Okay? So I break it here, and that's fine too. And I'll do both ways. So I'm going to break it this way, like this. Okay. So now you got to know some lengths. You basically got this rectangle here, and I'll kind of outline it so you can see the two different rectangles, but you have two different ones. You have this rectangle right here, like a long skinny one. And then you have this one, which I'll do in blue, is like this. More square looking. Doesn't mean it's a square, but it looks more like a square. The first thing I know is when I do this, I got to know a base and a height. Okay. Now, if I were to redraw that top one, the one in red, which, let me use red, then it would kind of look like this if I redrew it. Oh boy, I'm not even going to try to redraw it with this pen. Anyway, you can see that the base here in red, right here, it's going to be the same as this, right? Because remember, parallelograms, opposite sides are the same length. So this is the base, and then this, you could make that your height. So I know this is going to be area equals base times height, which is going to give me 20 times 3, which is going to be 60 feet squared. That's just that part. Okay? Now we'll go over to here and do this one, and this is where I'm going to see some mistakes. Okay? A lot of people are going to want to do base times height here and do 10 times 4, and that's just not the case, guys. This 10 is going all the way from right there all the way to the top of this figure. Okay, this is not the height of my rectangle right there. Okay, we need to know just this distance, just from here to here. Okay, well, I look here and I know that from right here to right here, that is 10 feet, right, guys? Because the reason I know that is because this over here is it's 10 feet from right there to right there. So I know it's going to be the same length there as it is there. So if I know that 3 of those feet go to right there, I just need to know the rest of it. So again, I'm going to take my whole distance, that's this whole thing is 10, remember, and I'm going to subtract out a part. And I know that this distance is 7 feet. Okay, this is 7, this is 3, 3 plus 7 is 10 total. Okay, so my base and my height here are 4 and 7, which means my area is 28 feet squared. Now I would be ready to add these up, okay, which is going to give me 88 feet squared. Okay? One more, last one, promise. I know this has been long, but it's going to benefit you guys on the test tomorrow, trust me. This is another shaded one, okay? You can see that this is all supposed to be shaded. It's really hard to tell, but it's everything that's not this is shaded, all right? Allie's laptop keeps her laptop on the rectangular desk. The area of her desk covered by the laptop is shown in the figure, okay? What is the area of Allie's desk that is not covered? So again, it wants you to basically not count this in the area. So again, you have to find the whole area. Whole area. Okay? I know this is 44 by 20. So area equals base times height. That's going to be 20 times 44, right? It's going to be 880 inches squared. That just imagine it's like this, guys. That's like if this wasn't here. It's saying, what is the area of that parallelogram? That's all it's asking. Then it's asking you to find the area of the laptop and just go ahead and subtract it out. Okay? So I know that the area of this is base times height, which is going to be area equals base times height. And then it's going to be 12 times 15, which is 180. So I know that my laptop area is 180. 180 inches squared. I'm trying to do a little square on there, but it won't let me. There we go. Okay, so what do I got to do? Well, I got to take the 880 of the whole desk, and I need to subtract 180, and I'm going to get 700 inches squared. Okay, and again, it makes perfect sense. Okay, if I took this 180 and I put it back into that, then I'm going to get 880. Right? So that's a basic thing. I mean, looking through the test, I pretty much went through every single thing you're going to see on the test, so there really shouldn't be any surprises. You always have the opportunity to go back and watch old videos. That's always an option. Or look through your notes, look through past worksheets, whatever. But I think the biggest thing you guys need to take away from this is right here. These three formulas. Because if you don't know the formulas, you are not going to do you're not going to do well. So I'll write them one more time for you. Area equals base times height. That's a parallelogram. A triangle would be area equals 1/2 times base times height. Okay, and then a trapezoid, the hardest one to remember, is area equals 1/2 the height times base 1 plus base 2. And what I saw today is I saw a lot of people that did not know these three formulas. I saw a ton of you. Now, if you're not one of those people, great job. But you need to know those. Make flashcards. Okay, do whatever you got to do. You got to know these things, all right? Hopefully you guys do well, so I'll see you.